Hello friends. In the world of programming, we all are very much accustomed with the word called thread. In fact, this topic is very popular among those students who deals with Java. We say that the main function runs on the main thread, or by default every program has got one thread, and that is called main thread. Now as you come to Android Kotlin, you have been introduced with something called coroutine, and this particular term coroutine is a bit confusing in regard to thread. So what I decide to do is, let me put an example over here and then I will get to this particular app. That is, consider there is a bus that travels on road, and passengers, they get in and out of the bus. So a bus is not based on what passenger decide to do. A passenger is a free entity, an independent entity. So if you have to travel to a particular location, you will get into a particular bus, right? Exactly the same thing over here. A bus is like a thread. The thread goes on, and the thread is maintained by the operating system, just like the bus is maintained by some authority, be that a government or a private sector. While on the other hand, the passengers, they get into the bus, and these passengers are coroutine. So coroutine needs a thread for its execution. A passenger, an independent entity, steps into the bus just like the way coroutines are created with a special way that is called lifecycleScope.launch, as you can see over here. So this lifecycleScope is associated, in this particular context, it is associated with an activity. Had this been a fragment, then the lifecycleScope would have been associated with a fragment. And .launch is actually going to create a coroutine. So what you can see right over here is there are two buttons out there. Okay, let me run the app, and then I will again get back to my explanation. Honestly speaking, this particular concept is not that straightforward. So for that reason, I'm giving an example. Like for example, which I was saying, that is a bus. Consider the bus to be this Android operating system. Okay, so the bus is traveling, the bus is working with the help of the Android operating system. Now this particular app, I'm talking about this specific app, has got two buttons. So I want to perform some functionalities for this particular button as well as for this button. And what I want is these two functionalities will work simultaneously. That is the main thing. While it is working, let's consider this first button is working, at the same time this button is also working. That means it's like a two passengers. So these two are the passengers, and they are like dealing their individual task while they are within the bus. And that's what exactly coroutine does. So you are creating multiple coroutines. So as I click on this button, a coroutine will get activated. Simultaneously, if I click on this button, another coroutine will be getting activated. So that means you can run multiple coroutine at the same time, and there will be no problem. So lifecycleScope.launch will actually create the coroutine in context to this activity. The same thing happens over here. Lifecycle.scope is going to create another coroutine as I click on this button. Now over here, if you notice, I did not mention any parameter, whereas I have mentioned a parameter over here. Why did I do this? Well, by default, if you don't mention any parameter over here, then automatically Dispatcher.Main becomes the parameter. Now who the dispatcher is? Well, the dispatcher is a part of coroutine only. That means, as I said, a passenger will be called passenger once the passenger gets inside the bus. Same thing, a coroutine needs a thread to work on. You cannot run coroutine without a thread. So coroutine has to be associated with some thread, and by default it is associated with Dispatcher.Main thread. Okay, so with the help of this thread, the coroutine is going to work. So that means there can be multiple coroutine associated to a particular thread. That's not a problem. They will work independently, and that's the beauty. So to execute asynchronous communication, you run the work parallelly without creating hindrance. And what coroutine allows us is it does not block the main thread. So the main thread is set completely responsive. It is not getting freezed. So whenever you are dealing with some operation that would take a bit of time, you would do this entire work on the background, and that's what coroutine does. So it creates a separate task that get executed in the background, not in the main thread. So that's the reason why I've written this small paragraph over here. Let me read out the paragraph. So lifecycleScope.launch, what it does, it's created a coroutine. So once you start this, a coroutine gets created, and this coroutine will be associated with this particular activity at this point of time. That means as long as this activity is active, this coroutine is active. If I destroy this activity, the coroutine automatically gets destroyed. Hence it is much safer. It will not block the resource, and that's the reason why it is said that is associated with the life cycle of an activity or fragment. That means once the fragment changes or once the activity changes, the coroutine also get disposed. Second important point, the coroutine require a thread to execute, and that's what I said. Even if you are not writing a parameter over here, but by default there would be a parameter, and that is called thread. So this coroutine require thread to execute, and by default it will use the Dispatcher.Main thread, which is actually working on the main thread itself, or the UI thread, you can say so. So similarly, suppose if you want to give a call to a retrofit, or you're giving a call to an API, at that point of time we will be using something called Dispatcher.io. So based on different tasks, we have got different dispatcher, or you can say the thread has been segregated. So at this point of time we are working on the main thread, and in fact I have a plan to make a next video where I will be showing how to work with coroutine in context to retrofit as you're giving call to REST API. So the coroutine always needs a thread to run on, and the dispatcher determines which thread to use exactly. As you can associate that, as you can see over here, the Dispatcher.Main will be the part of both the thread, and they will work simultaneously. Okay, let me show you what I have done over here. So here is my edit text. Let me write something like, okay, let me write my name over here, Swarup Kumar. I wrote over here, right? And now I have got couple of buttons. So if I click on this, what is going to happen? It will take the string from this edit text, and it is going to launch a coroutine, and it will associate the coroutine with the Dispatcher.Main, even though it is not mentioned over here. Remember, this is a thread, and coroutine needs a thread. It will be the part of the thread. Thread is like a bus, and the coroutine is a passenger. So passenger need a bus, and then only it will be a passenger, isn't it? A person walking on the street is not a passenger. Unless and until you get into the bus, you are not a passenger. You need a transport, and the transport is a thread, and any individual who is inside the bus is actually a coroutine. You can share this example. And here I'm going to do what, there will be delay. This is what I was trying to say, that if you're not using coroutine, then your main thread would have been freezed because you are going for delay. So there would be a delay of 5 seconds. Until then the message will not be shown, it will be just showing waiting. So once the 5 seconds gets elapsed, and then whatever name I have given, that will be shown in this particular text view. So that means with the help of delay, you are delaying an operation, and delay is again the part of coroutine. So remember, if coroutine was not there, your main thread would have been freezed, and you will not be allowed to work simultaneous action. But with the help of coroutine, I will be able to do another operation. So at the same time, I will click on this button, and what it does is it's going to launch another coroutine on the top of the main thread only. And this coroutine is going to do what? It's going to go for it will show the counters. Okay, it will start from 0 and it will go up to 1. So there will be a countdown from 0 to 9, 9 to 8, 8 to 7, 6. In this way there will be a countdown, and again while the countdown is going on, the countdown number will stay on the screen for 1 second. So it will hold that number for 1 second. Again over here the delay is there. Now the beauty is that both these operations will happen simultaneously, and that's what the coroutine is capable of doing. Asynchronous communication. You are doing two separate operations on the same main thread without blocking your main thread. and that's how it works. And once the countdown completes, then it will show the message called done. So this done message will not come until the countdown does not get over. So let's go and see how it is working. Please be careful. This is a 5 seconds, so it will come much faster over here. But to make it a little bit, so I will do what I will make it like, I'm just increasing the time over here, so I make it like instead of going 5 seconds, I made it 10 seconds. Okay, so after 10 seconds the name will flash over here, and let's go for this one. Is I'm changing it to suppose 20. I made it 20 seconds. 20 seconds there will be a delay. Sorry, this message will be for 1 second, and here I will run this. I will increase this loop to 20. That I will do it, or 15, but I will do it 15, otherwise it will take time. 15. Okay, so let's get and watch how the thing is working, and let's see how the coroutine does the work simultaneously. And that's the beauty, because it will work behind the scene. At the background thread, asynchronous communication will be going on, and there will be no hindrance in your main thread. So let me write my name over here. So I wrote my name, and now what I will be doing is that I will start this button fast, because it's going to run 15 times, and this is just for 10 seconds. Alright, so there will be, it will take more time over here. So let's start with this one. See, it has started, countdown has started, and let's click on this. It is waiting. It's waiting for the 10 seconds to elapse. So it's waiting, and while this is going, the countdown is going on, and it will be, and see, it's the name came over here much faster, and now it will showing the done. You got to see how the thing work. Okay, let me show you once again how the thing is working. So for this reason, let me increase this a little bit more so that you can see it more perfectly. Let me run the app once again, and you see both the tasks is happening at the same time. Okay, let me change the caption over here. You might think that it's 5 seconds written over here, so let me close this. Let me come to my XML over here, and I will change this caption from 5 to 10 seconds, because there is a delay now in the 10 second, right? So let me close this. Let's come over here, and let's run the app once again now. And as I do that, over here the device manager, so yes, here it is, and here the app is in front of us. So let's go for Peter Parker this time. Okay, I love this character. Okay, so now what I will do is that I'm clicking this particular button. As I do that, see, this countdown started, and let me click this as well. So here is going to get to 1, and this is waiting till it elapses 10 seconds, and once the 10 seconds get elapsed, this message will flash over here, and see, at the same time this work is also happening. So simultaneously both the operation is working, and that is possible because of coroutine. Okay, so from this particular app you understood that what is a coroutine all about, how exactly the coroutine works, and what is its minimum requirement. Its minimum requirement is that the coroutine should be associated with either a activity or a fragment, and second thing it needs, that is called a thread, and by default it's going to be Dispatcher.Main if you are working on the UI like what I did over here. But if you are going to give a call to the network, then there will be Dispatcher.io. Got it? And finally I gave you an example. You can share this example, that is a thread as a bus. A coroutine are the passengers that get into the bus, stays for a while, and then steps down. So coroutine can work for a particular span of time, complete the work, and then other coroutine can also do the work simultaneously at that point of time. Okay, that's beautiful. Let me run this app once again. I just fell in love with this one. Oh, sorry. I know. I was supposed to omit this one. Yeah. Suppose I loved another character. It's called Raj Aryan. So let me now run this app, and as I click over here, waiting starts, and as I click over here, the countdown starts, and see both are working simultaneously. How beautiful it is! And this is what we see in the modern app. Suppose when you're working on WhatsApp, what do you see? Parallelly, you are chatting with multiple people, you're downloading something, you are uploading something, and it doesn't create any hindrance in the app. And this is all the part of coroutine process under the segment called thread. Okay, in my next video I will be showing you how coroutine can be implemented with the help of retrofit for giving a call to a network, and that is the REST API. Okay, so until then, have a nice time. Bye bye.